Hello guys and welcome to Unity mobile game development course for Android and iOS. In this course you will learn how to create a Subway Surfer like clone in Unity game engine. In this course you will learn how to create a professional runner player controller which can do many moves like jump, slide, move left and right. You will learn how to create a UI and able to control that UI. You will learn how to add sound effects to the game and able to control that sound effects from the menu, and you will be able to create many menus like the missions menu, and this menu will update as well, and you will be able to learn how to add different characters to the game and play game using that characters. As you can see right here, the player can collect coins and there is a score system as well, and also the top run score system as well. Also, when the player touch any obstacle, the player will fall to the ground and then the player will simply need to restart the game. Then you can change the character as well, and there is also a pause system as well, just like Subway Surfer. The player can jump over many obstacles. As you can see, the player can dodge all of these obstacles as well, and the player can, as you can see, collect coins. Also, there will be a high score system. So now, as you can see, the player make high score, and in the top run you can see the high score is showing. Now when the game gets over, if you click on missions, as you can see, now the missions are updated. Alright, when the mission are completed in a single run, then that mission gets updated. So let's go ahead and open up Unity Hub. Then right here click on this new project. Alright, make sure that you select the universal 3D pipeline for this game, okay, and then select the Unity organization. Then right here you can name your project whatever you want. I'm gonna name this as Subway Runner. Alright, then you can select the location and then simply click on create project. Once the project is created, you will see an interface like this. Okay, this is our project now. Right here you will find these three windows: scene, animator and game. On the game window, make sure that you change this option from game to simulator, and then if you want to see some other mobile devices, then you can click on install additional devices. But since I will be testing this game on an iPhone, so I'm just going to select the Apple iPhone 12 right there. Okay, with this done, let's end this video right here. Now in this video what we're gonna do is to set up the game environment. Alright, for that go ahead and download this zip file which is by the name of Subway Runner Game Assets. In here you will find these three Unity packages. So let's start from the first one, which is the environment. Just simply double click on it. So when this window opens up, you just have to simply import all of these things. Alright, so let's click on import, and in few seconds it will be imported. You can check this game assets folder right here, in which we have this trainway runner, in which we have this prefab of the environment and the scene. So right now we are on the sample scene. We will now click on this scene, trainway runner scene, to open it up, and now as you can see it is opened up, in which you will find this whole environment already set up with the spawner, ender, spawn here. Okay, all of these things are set up. So what you need to do is to leave this environment as it is. Alright, don't change this environment position or else there will be problems then. Alright, so you will just leave this environment as it is, and as you know that from this position our game will start from this point in the forward direction. Alright, and in this environment, as you can see, all of the box colliders for the coins, for the trains and other obstacles, for example these bushes, the box colliders and everything is already added. Alright, as you can see for these pillars. So the whole environment is already set up. Okay, so once the environment is set up, okay, then let's add the other things, which is the characters. Alright, so let's double click on it. It will open up the Unity package window. Simply click on import, and in the game assets folder you will find this character folder now, in which we have the animations right here. Okay, the animations rig is already set up. Okay, for all of these animations the rig is set to humanoid, and then the avatar definition is set to copy from other avatar, and then in here I've selected the Jack avatar. Okay, and right here we have these two characters. The first one is the Jack character, which is the classic character for this game. Okay, on this character, if you check the character rig right here, it is set to humanoid, and then the definition is set to create from this model, and then just click apply. Okay, if you're using the same two characters, then you are good to go, but if you're using some other characters, then make sure that characters are humanoid, and also you can find animations on the miximo.com website. Okay, for this game I have these animations which is from miximo.com website. If I show it to you, it is this website. Okay, miximo.com. You can click on animations, and then from here you can download your animations for your own character. Okay, you can upload the character and then download the animations which you find suitable for your own Subway Runner game. Alright, but I'm already providing you these two characters and these animations, so you can use these two characters and the animations. Okay, everything is set up, you don't need to change anything. Okay, now let's test the second character, which is this Tricky. Okay, this is another classic character for this game. Its rig is also humanoid and then create from this model. Okay, and let me tell you, these animations work on both of these characters. Okay, if you want to add some other characters, then just simply add other characters, but just make sure that their rig are humanoid, and then it is also the definition is set to create from this model. Okay. Alright, so this was all about the characters. Okay, and the environment is, as you can see, set up. Now the final thing, which is the font. So let's add the font. Okay, just double click on it, it will open up this Unity package. Just simply click on import. Okay, now if you click on this font, it is right here. Okay, I have downloaded this font, which is by the name of Titan 1 regular. You can use any other font for your game text. Okay, but I will be using this one. So once the environment, characters and the font is added, now from the next video we will start working on our game. Okay, we will move our character in this whole environment. So catch you guys in the next one. Okay, so now what we're gonna do is make the player move in this environment. Okay, for that let's click on character. Let's start from the Jack character. Okay, so I'm gonna select the Jack character and let's drag and drop him right here. Okay, let's move him up so that he is placed on top of this railway track like this. Okay, and make sure that this character is in the center. Okay, and make sure that you are on the scene view, not on the simulator, on the scene view. Okay, as you can see on this character we have the avatar added because this is a humanoid, so when you drag and drop the character, the animator will be already added. And also if you click on this jack.controller, double click on it, as you can see it will open up this whole animator controller for this Jack. Okay, and what we did in this controller is that on the parameters, as you can see, we have these parameters: is sliding, is jumping, die, and then game start. Okay, these first two are bool, and then this one is a trigger, and this one is a bool again. Okay, and if you check these animations, first we have this idle. Okay, as I told you in the previous video, where we have this animation. So the first animation is the idle. So when the game is not started, okay, and it shows tab to start or tab to run, the character will play this idle animation. Okay, when we tap it, then the character will transition into this running animation. Okay, so in order to transition it, we make a transition from idle to standard run, okay, which is this fast run animation. In the transition, we remove the as exact time and we set the condition right here. The condition is we set the game start bool to true. Okay, then when the character is running, okay, and then for example, if there is an obstacle from which the character need to jump, okay, so for that we have this jump animation. So if you check this jump animation, okay, for all of the animations, let me tell you that for all of the animation it is set to loop time, loop pause. These three ticks are right there, and then the based upon is set to original in all three of these options. Just for the jump animation, and yes, for the roll, for the jump and the roll animation, the loop time is not set. Okay, it is just loop pause. In order to set loop pause, you have to select loop time, then select loop pause, and then remove that, and then click apply. Okay, in this way you can set that up. Alright, so when the character want to jump, we have the jump animation right here, but of course we need to transition to jump. So we make a transition from run to jump, in which we set is jumping to true, and then when the character is done jumping, then we set is jumping to false, as exact time is false. Now if the character want to roll under an object, then we have this animation for the transition, as exact time is false, is sliding is true, and then right here is sliding is false when we want to get back to running. Okay, and then for example, if a character hits some object, okay, so the character can be in any state. The character can be jumping, sliding, or running. Okay, so then from any state, okay, we make a transition to this fall flat animation, which is this. Okay, for this animation, you can see these settings right here. It is loop pause. This tick is not right there. It is set to original, and then everything is default, as you can see. Okay, so in the transition we set just die, because die is a trigger, so we trigger the death in this way. Okay, and also you can move around these entry or this exit wherever you want, but I set this up like this, so you can set it up like this as well. Okay, and the same animator is for tricky as well. Okay, I've just duplicate this jack, name it as tricky, okay, rename it as tricky, and then I have copy and pasted that in this character. Okay, so all the animator for all of the characters will be the same. Okay, so for the jack we have the controller right there set up. Okay, so in order to play these animations, we just need to drag and drop this controller in there. Alright, so the animation part is done. Now we need to add a character controller. A character controller is like an engine, okay, which will run our character. Okay, there are two type of components from which we allow our character to move around in the environment. One is character controller, one is rigid body. Okay, you can check this out on the Unity documentation. I will not explain these things since most of you guys are familiar with Unity and all the components of Unity. Okay, so we will be using character controller, as I told you. In this character controller, everything will be the same. We just have to change the height to 1. Okay, as you can see, if you turn on the gizmos from here, then you will be able to see the character controller. Okay, so I've changed the height from 2 to 1, and let's change the radius to 0.2, and let's change the center value to 0.6. okay, so that the character controller is right there. Alright, then in the game assets folder, we need to create one more folder by the name of scripts, And inside the scripts, let's create a mono behavior script. Name this as runner player controller. Alright, when the script is created, click on Jack and drag and drop this script. Okay, then you can double click on it in order to open it up in your text editor. For my text editor, I am using Visual Studio Code. Okay, you can use whatever text editor you want, Visual Studio or Visual Studio Code or some other text editor which you are comfortable with. Okay, so this will be our script in which we will add all of the logics for movement, for jumping, for sliding, and for the death, or as you can see, for the hit, when the character hit with any obstacle. But for now, let's just minimize our text editor and click on Jack. Alright, right now we don't have any camera in our environment, so let's go ahead and add a camera. For now we will just add a simple camera inside the jack. Okay, so if you click on jack, right click on it and then click on camera, it will create a camera like this. As you can see, the camera is now loading, so let's just wait for it till the shaders are fully compiled. As you can see, now the camera is in the player feeds right here, so we just have to move it back. Okay, now as you can see, there is our character. Let's move it back a little bit and a little bit up. Alright, let's move it up. That's it. Okay, this view is good. Alright, let's move it a little bit closer. That's it. For now, since the camera is a child of the character, so this camera will move constantly with the player. Okay, for now we are not working on the camera controller, so that's why I have put the camera inside the character just for now. Okay, we will be creating a separate camera controller, so don't worry about that. Now there is our camera setup, and this is the player. We have the script right here. And in the next video, we will start working on our runner player controller. So catch you guys in the next one. Okay, so what we're gonna do right here is at the top, first of all, we will add the system.collection. Alright. After this, we will remove the start and update method, and at the top, let's declare all of the variables. So first of all, we will start from the movement variables. Okay, I'm gonna create a header by the name of movement settings. Alright, and in here I'm gonna create a public float. Let's name this as forward speed. This will be equals to 8. Then we're gonna create another float by the name of lane distance. This will be 2. Then we will create another float by the name of horizontal smooth. Alright, by default this will be 10. Then we will create another float by the name of jump force. This will be 6. Then create a float by the name of gravity. It will be -22. Then the last float, which will be by the name of slide duration, and you can guess it by the names what these variables will do, so I don't need to explain that. Alright, then as you know that we have added two components to our jack character, the animator and the character controller. So we need a reference to both of them right here. So let's create a header by the name of reference. Let's actually make it references. Then we will say public animator, name this as animator as well. Then the next one will be the character controller, so public character controller. Let's name this as controller. After this, we need a private integer. Name this as desired lane. And by default, this will be 1. Okay. So what this desired lane integer will do. Okay. So when its value is 0, it means the character is on the left side. Okay. Or as you can see on the lane which is left to the character, okay, which is this one right here, okay. So if it is 0, then it is left, and when it is 1, it means the character is in the center, just like we set it right here, okay. When it is 1, it will be center, and then when it is 2, it means the character is on this line, which is the right side. Got it. Now let's make one more private float. Name this as vertical velocity. By default, set it to 0. Then a private bool. Name this as is sliding. Avoid, by default it will be false. Now when all of the variables are set up, now what we need to do is actually create the movement. So for the movement, now let's create the update method, and in the update method we will now type our movement code. Okay, so let me add a comment right here. Let me type movement code, player movement code here. Alright, now what we're gonna do for the movement is, in a infinite runner game, as you can see, in most of the games, Subway Surfer or Temple Run or any other, in all of them the character moves in only one direction, which is the forward direction. Okay, so first of all we need to do that. So for moving the character in the forward direction, we will create a vector 3 by the name of move. It will be equals to vector 3 dot forward. Alright, and then of course to that forward direction we want to add a speed, or as you can see or as you can say, a movement speed. Okay, so that speed will be the forward speed. Alright, so it will move in the forward direction using the forward speed, which is 8 right there. Now after this, let's add horizontal movement. So for the horizontal movement, we need to calculate the target X position based on desired lane, okay, which is left, right or center. Okay, as I told you, we have this desired lane right here. By default it is set to 1 because by default we want the player to be in the center. Alright, so create a float, name it as target X, then around brackets we will add desired lane -1, multiply that by the lane distance. Alright, and the lane distance is 2. So this will calculate the target X position based on desired lane, and the desired lane is 0, 1, 2, which is left, center and right. Now after this, let's smoothly move towards the target X using linear interpolation. Okay, so for that, create a float by the name of new X. It will be equals to mathf.lerp. Then we need to provide the position X, so transform.position.x, then provide the target X, and then we will say horizontal smooth, and we're gonna multiply that by time.delta time. After this, what we're gonna do is we're gonna convert the position difference into velocity for constant movement. Okay, so move X equals to new X minus transform dot position dot X, and let's divide that by time dot delta time. Alright, so this will be our horizontal movement. Let me add a comment right here by the name horizontal movement. Now let's add the vertical movement. Alright, so we're gonna make a comment right there so that we know where is our vertical movement. Okay, for the vertical movement, first of all, we're gonna make sure that if the character is grounded, and yeah, that's it. So if it is grounded, then we will say if controller is grounded and also the vertical velocity is less than 0. Alright, then what we're gonna do, okay, this actually means if the character is grounded and also falling. So if that is the case, then if the character is falling from a train or during jump, then we're gonna apply some small downward force to keep character grounded. And in order to do that, we will make the vertical velocity -1, and we will say animator dot set pool is jumping, and we're gonna set it to false. Alright, this is the boolean in our animator parameters, which I have shown you in the previous video. Alright, so this is for when the character is grounded. Alright, when the character is not grounded, and let's just say the character is in the air, then what we're gonna do, we're gonna apply gravity when the character is in air. So we will say vertical velocity plus equals to gravity, multiply that by time dot delta time. That's it. Then outside this if condition, we will apply vertical velocity to the move vector. So move dot y equals to vertical velocity, and then let's apply the final movement vector to the character controller. And as I told you, the character controller is like an engine which runs our character. So controller dot move, and then we will pass the move, and we're gonna multiply that by time dot delta time. So now this will be the whole code for our player movement. Okay, we can now just copy all of this code, click actually press Ctrl X, and then right outside the update method, let's create another method by the name of player movement, and in here we're gonna paste this whole code. Alright, and then copy this method name and paste it right here in the update method. Alright, now our character should move in the forward direction. Our character can also move to the left and right as well, since we have both the horizontal and vertical movement, but for now we didn't set up the buttons. Alright, because in this game the character can move to the left and right, jump and slide using keyboard and also using touch swipes. Okay, but first of all we will be adding the buttons, but for now let's just test this whole player movement and see if it works or not. So get back to Unity, click on Jack. Here is the script. All the values are set up. Make sure that you make the step of set of this player as 0. Alright, then we need to apply the animator and the character controller. That's it. After that we can just simply go ahead and run the game. Alright, as you can see, the character is moving. The character is in the air now, gets back to the ground because we apply gravity to it, and the character moves inside this game object. That's okay. our focus was on the movement, and the movement is working perfectly fine. Now we just need to make the player jump, slide, move to the left and the right side. Okay, so in the upcoming videos we will be doing that. Okay, so now let's go ahead and add the controls to our player controller. Okay, for now we have the movement, which is the forward movement, and also our character can move to the left or right side. Okay, so for now we're gonna control that movement using our keyboard keys. Okay, so for that, open up the runner player controller script, and right here let's create a new method. We're gonna name this as PC controls. Alright, and in this PC controls, let me make this C small. Now it looks good. Right here we will say hash if. We then gonna say unity underscore editor or unity underscore standalone, and then right down below we will say hash and if. That's it. Alright, now in here, okay, this will automatically move to the left side, so you can't leave it in here, as you can see. Okay, so we will leave it there. Now in here we're gonna type the controls, but let me tell you what this if and if means. This block only runs in the Unity editor, or you can say the standalone builds, like not on mobile, it will only work on PC. Okay, now we want to move our player to the right side. Okay, so for moving the player to the right side using the keyboard, we're gonna use the right arrow or the D key. Okay, so for that we're gonna say that if input dot get key down, and if that key code is dot right arrow. Alright, and also as I told you, we'll move to the right side using the D key, so we will say input. Actually we're gonna just copy this whole thing right here, add a round bracket and remove this one round bracket from there. Okay, now let's copy this whole thing and paste it right there, and instead of the right arrow we're gonna say keycode dot D. Alright, then let's add curly brackets, and in here now we need to move the player to the right side. So as I told you, for the right side, this desired, where is it, this desired range should be 2 in order to move to the right side. Okay, so we will say desired lane equals to mathf dot minimum. Let's pass the desired lane, and then we're gonna say plus 1 and then 2. So what this will basically do is move the player to the right side. It will increase the desired lane but clamp it to a maximum of 2. Alright, so when the desired lane value is 2, it will not increase from that, because of course we only have one spot on the right side and one spot on the left side. Of course we don't want to move further to the left or to the right side. Okay, we just want to move only one time, so that's why its maximum value should be 2. Okay, now after this we want to move to the left side, so it will be the same as the right side, so we can just copy and paste it, and right here instead of right arrow we will type left arrow, and instead of D we will say A, and for this we will use -1 and its maximum value should be 0, because if it is 0, then it means the player is already on the left side, and if the player is on 1, then from 1 we will minus 1 so that it becomes 0, and when it is 0, as I told you, it will be then left side. Alright, now for jumping and slide, of course we don't have a method for jumping or sliding, so for that we will just skip the buttons for now. Okay, so just save this, and we need to call this PC controls inside the update method. So make sure that you call it right there. Save the script, get back right here, and make sure that if you are in a simulator mode, make sure that you change back to game mode, because the keyboard inputs work in the game mode only, okay, not on simulator, since that is a mobile device. Okay, so change to game mode, and then right, let's just simply now play the game. It will show an error. Let me show you. As you can see, the buttons doesn't work, and it also show this error, which is you are trying to read inputs using the Unity Engine.input class, but you have switched active input handling to input system package in their settings. Okay, if you are getting this error as well, then just clear this out, then click on edit right here or at the top, click on project settings, then click on player, then under this other settings, let's find the active input handling, where it is. Alright, right here we have this active input handling in configuration. As you can see, it is set to input system package. You have to change it to both. Click apply. As you can see, it will automatically restart the Unity project, so let's just wait for it. Once it is restarted, let's close that window and simply play the game. When the game is played, as you can see, the player can now move to the left and right side. As you can see, the player can move infinitely to the left side and also to the right side. We type a code for this so that the player doesn't do this, but as you can see, the player is doing it. Okay, so we need to stop the player from doing this thing. And the reason it is doing this is because right here by mistake we type minimum. This should be max, or you can say maximum. Alright, change it to max, and when you change it to max and then play the game, the player will not be able to move outside these three areas, as you can see. Alright, the player can go past these objects for now because we don't have any obstacle detection, but as you can see, it works perfectly fine now. So now in the next video we're gonna add jumping and sliding to this controller. So for that, see you guys in the next one. Okay, so now let's go ahead and add jumping and sliding to our controller. Alright, right after this method, which is PC controls, let's create one more method for the jump. So we will say public void jump. Alright, and in here what we're gonna do is we will only allow jump if the character is grounded. Alright, so we will say if the controller is not grounded, then simply returns, because we don't want to jump. And if the character is already grounded, then we want to jump. So let's set vertical velocity to jump force to initiate upward movement. Alright, so we will say vertical velocity equals to jump force. Alright, then let's trigger the jump animation. So we will say animator dot set bool. Let's set the is jumping bool to true. Alright, now for the slide, let's create a method as well. We will make this one as a private enumerator. Name this as toSlide. And here what we're gonna do is we're gonna set the sliding state to true. So we will say is sliding equals to true. Then let's trigger the sliding animation. So we will say animator dot set bool. Provide the animation animator boolean name is sliding. Set it to true. Alright, when we trigger the animation, after that we need to store the original character controller values. So we will say float original height of the character controller will be controller dot height, because as you know that when the character slides under any object, of course we want to decrease the character controller height. Alright, so that the character slide inside that obstacle without hitting it and failing the game. Alright, so that's why first of all we need to store the controller original height and also the controller center position, so that we can give it back after we are done sliding. So we will say controller dot center. Alright, after storing this, let's reduce character height and center to stimulate sliding. Alright, so we will say controller dot height. It will be equals to the original height and we will divide that by 2. Then we will say controller dot center. It will be equals to new vector 3. Let's pass the original center dot x to it, and then the original center dot y to it, divided by 2, and then the original center dot z. Then let's wait for the slide duration, because we want the whole sliding animation to finish. So we will say yield return new, wait for seconds, and we want to wait for the slide duration. Alright, and the slide duration is this value, which is 0.68. It is the animation duration. Okay, I've counted the animation duration, it is 0.68. So if you're using some other slide duration, slide animation, then make sure that you set up its duration accurately. Okay, now after this, when we are done sliding, we want to restore original height and center value. So we will say controller dot height. It will be equals to the original height, and then controller dot center, and it will be equals to the original center. After this, we will say animator dot set bool. We want to set the sliding to false. Alright, and the sliding boolean will also be set to false. After this, right here, after the jump method, let's create a public void. Name this as slide. I don't know why it just tried to correct that. Okay, so we will name this as slide, and in here only slide if not already sliding and the character is grounded. Okay, we want to do this, so we will say that if the character is not already sliding and also the character is grounded, because of course we don't want to slide in the air. So if this is the case, then we will say start coroutine, and let's call the doSlide method in here. That's it. Now we need to slide using the down arrow button or the S button, and we want to jump using the space button. Okay, so let's set that up quickly. So right here we will say that if the key pressed is the up key or up arrow, or if it is the space key, then what we want to do, we want to jump. Alright, so in here just simply call the jump method, and then you can actually copy this again and paste it right down below. Then for sliding we want to use the down arrow button, so we will say if it is the down arrow button or the S key. You can also set up the C button as well for sliding. I'm going to just use S, and then if any of this button is pressed, then we want to slide. That's it, and this PC control is already called inside the update, so we are good to go. Right, so let's get back right here, click on jack. Let's open up the jack animator controller, and right here as you can see the idle animation is the default one. For now we will not set this idle as the default. For now we just want the standard run to be the default. Okay, and you can also do this for tricky as well. Set standard run to default. Alright, then just simply go ahead and play the game, and you will notice the character is running. The character can jump, as you can see. Alright, it's just stuck in the jump animation, so we need to check that out, why this is happening. But now as you can see, when it jumps 2 to 3 times, it gets stuck in the jump animation. It is loop pause, not set to loop time. Okay, everything is good. Let's test again. Alright, the character is running, jumping. The character can go down. As you can see, the character can slide, or you can say the character can roll, change sides, jump again. Okay, everything works. And of course we don't want that. When the character hits this area or any other object, we want the game to be just end. Alright, so now the animations work. The character can move left, right, jump and slide as well. So this is pretty much it for a controller, and for now let's end this video right here. Okay, so our character controller is completed. Now we need to work on the camera controller. For now, as you can see, the camera is inside the character and the camera movement is not that good. So we need to move the camera outside the character, and for this camera we're going to create a new script. So click on scripts folder, and right here let's go ahead and create a new script by the name of camera follower. Let's open this up. In here let's remove the start and update method, and at the top let's add a header. We're gonna name this as player characters, because we want the camera to follow any player character that is currently playing the game. For example, Jack or Tricky, or if you want to add some other characters, then you can add them as well. Okay, make sure that you make this as an array, since we will have many characters. Okay, then let's make one more header. This time name it as offset settings. And in here we're gonna create a public vector 3, name it as offset, and we're gonna set its value. So we will say new vector 3, its x value will be 0, y will be 2.6, and z will be -5. Alright, then we need to create one more header by the name of follow settings, and right here we're gonna create these 4 variables. Alright, the first two will be of type float and they will be public. The first one is follow smoothness, it will be equals to 0.1. The second one is a float as well by the name of rotation smoothness, it will be 5 by default. And then we need to create a private transform by the name of current target and a private vector 3 by the name of velocity, which will be vector 3 dot 0. Now let's make the camera follow our player. Alright, and set up the camera position and offset and everything. Okay, we're gonna do that in the late update. Whoops. Alright, late update in here. Let's first of all say that if no target is found, then we don't want to do anything with the camera, which means if there is no character, that we don't want to do anything. So we will say if the current target is null, then just simply returns. Now after this we will calculate the desired camera position based on the target position plus the offset. Okay, so first of all let's create a vector 3, name this as desired position, it will be equals to the current target dot position plus the offset. Alright, after this we will smoothly move the camera to the desired position, so we will say transform dot position, it will be equals to vector 3 dot smooth temp. Alright, then we will add round brackets, semicolon, and let me move this down like this. Alright, and in here we will first of all say transform dot position, then we will pass the desired position, then for the current velocity we will pass the velocity, and then for the smoothing time we're gonna pass the follow smoothness. Alright, after this we will determine the desired rotation. Alright, which means the camera should look in the direction the target is facing. So we will say quaternion, name this as desired rotation, it will be equals to quaternion dot look rotation. Let's pass the current target dot forward to it. Alright, then we will smoothly rotate the camera towards the desired rotation, so we will say transform dot rotation equals to quaternion dot slurp, and now in here we need to pass some values, so let me do that. And first of all what we're gonna do is we're gonna pass the current rotation, so we will say transform dot rotation, then we need to pass the target rotation, so we will say desired rotation, then we need to pass the interpolation speed, so rotation smoothness, multiply that by time dot delta time. That's it. Now we need to find the current player which is active in the game and make that player the current target. Okay, So for that we will create a separate method by the name of update target. Alright, in here we will automatically find the first active player, okay, which means the enabled player in the player list. For now we don't have the player list because we have single player, but when we will have a player list then it will choose the active player from that, okay. And for choosing an active player, of course we will have to go through the whole list. So for that we need to create a for each loop in which we will create a transform by the name of player, and we want to check inside the players array, which is this array in which all of the players will be. Then we will add if condition. We will say that if the player is not null and the player is active in the hierarchy, so we will say player dot game object dot active in hierarchy. So if it is active, then that will be our current target. So let's set it as our current target. So current target will be equals to that player, and then we will just simply return from there. Alright, and if no active player are found, then the current target will be just simply null. Alright, now let's copy this method name, move up right here above the if condition, paste it, and make sure that at the end you add a semicolon. And this will be it for the camera follower script. Now save it, get back right here, click on camera, let's drag and drop this script to it. As you can see, this is our player list. For now we just have one player, so just drag and drop that player in there. The offset is already set up. Alright, and the follow smoothness and rotation smoothness is already set up. If you want, you can change these values according to your own liking. Okay, now if I play the game, you will notice that what all these values gonna mean. Okay, so as you can see, this is our camera. As you can see, when you change the offset Y, it moves up down, and if you change the Z, it zoom in, zoom out, and this is for moving left and right. Okay, and then this is the smoothness speed. So you can keep this a low value so that it works perfectly fine, because if it is a higher value, as you can see, the player will move really fast then. And this is the rotation. As you can see, the camera rotate really slow like this. Okay, so the values which I chose, which are these values, they work perfectly fine on this camera controller. And of course, if you want, you can change them as well. Okay, as you can see, these values just works perfectly fine. Alright, so with our camera follower script completed, let's end this video right here.